All right, we're looking at the last of the lesson, or unit 4, lesson 4, powers and roots of complex numbers. The objectives here: expressing powers of products, de Moivre's theorem, examples with de Moivre's theorem, the fundamental theorem of algebra for some weird reason is showing up, I guess, and finding roots of complex numbers. Uh, we're going to explore it. It's going to be good. Um, so powers as products. Remember that x squared is x times x. Okie dokie. X to the third is x times x squared. Okay, so they just broke up one of them, right? Which is x times x times x. So they're breaking up one of them every time. Okay, no problem. So we could say x to the n is x times x to the n minus 1, and that's expressed x times. No, I'm not going to do all that. All right, so it says, what does RCIS theta squared equal? Which I think is really pretty cool. Kind of a neat thing to think about. So it would have to be R CIS theta times R CIS theta. And when we multiply complex numbers, we multiply the moduli, right? The absolute values or the R value. So R times R gives us R squared. And then we add the angles. So CIS theta plus theta. So we would end up with R squared CIS 2 theta. Okay, so now it wants to do that a whole bunch of times. And I have no problem with that. I'm going to skip to, instead of doing it 3 times, I'm going to say R CIS theta times R squared CIS, oh, 2 theta, right? And we know what that one is. So then we would end up with R cubed CIS 3 theta. I can see a little pattern here, right? I didn't want to do theta plus 2 theta, that's the whole thing. But the pattern is we got R to the fourth CIS 4 theta, which gives us R to the n CIS in theta, right? We saw the pattern develop pretty quickly. At least I did, and I hope you do too. If you needed to expand that out, right? 1 theta plus 2 theta is 2 theta, right? Do we need to do R to the first times R to the third to know that we would have R to the fourth and a theta plus 3 theta to get 4 theta? I don't think we needed it. That's me. Throw it out there, but I feel like that one we can get to pretty quick, right? Okay, sweet. That's all that whole entire page had. The mob theorem says exactly that. It says if we have some complex number, R CIS theta, then Z to the n equals R to the n CIS n theta, which is exactly what we thought it would be. Now they put a caveat here that R has to be rational, or excuse me, n has to be rational, that's just fine. But that opens up some possibilities, right? Because that means we could have fractional exponents as well? Question mark. I wonder what that would mean. I wonder. All right. Express the following in polar form and simplify the result. Okay. Not a problem. 35 degrees. All that raised to the fourth power. So we get 2 to the fourth CIS 4 times 35. Oh, goodness. Now we got to do this. 2 times 2 is 4, 8, 16. So we get 16 CIS and 4 times 30. I say 4 times 30 is 120. 4 times 5 is 20. So we get 140 there. Degrees. Okay. not too bad. We have root 2 CIS pi. Okay, so that gives us the square root of 2 raised to the 6th power CIS 6 times pi. So that gives us Magnolia Jones. I love you, honey, but I'm trying to record this for my kids at school.
Okay.
You want to say something to them? If you had to say something, what would it be?
Hmm?
You want to say hi?
You
You're
can
not going
tell
to tell them that you lost it too?
you can tell
I'm
them.
not going to tell them that. I am not going to tell them that you're adorable right now.
You too.
Yeah. I'm not going to tell them that you just lost a tooth.
Can you just whisper it?
Yeah, I'll whisper it. What do you want me to whisper to them?
You make it feel good.
My dad
My dad
is
is
the
the
tallest math teacher.
tallest math teacher.
Oh, why would you want to tell them that? That's silly goose stuff right there, pal. All right, love you, bye.
No,
Okay.
the handsomest, the handsomest.
The handsomest man. Okay. All right. I'm with you on that one, pal. Well, we agree on one thing. All right, so square root of 2 to the 6th power. So the square root of 2 squared is 2. So that would be I need 1, 2, 3 of those. So the square root of 2 to the 6th power would be 2 to the 3rd. You know what I like about that though? The square root. Do you remember the bth root of x to the a is x to the a over b? You remember that? That would mean that the square root of 2 to the 6th is 2 raised to the 1/2 power raised to the 6th power. And do you recall that x to the a raised to the b power is x to the a times b? So that means 2 raised to the 1/2 raised to the 6 is equal to 2 raised to the 1/2 times 6, which is 2 to the 3rd. Oh, beautiful. Love the laws of exponents. Thank you, Algebra 1. And then 6 pi. So we have 2 to the 3rd. Shoot. 2 times 10 to 4, so that's 8. CIS 6 pi. Final answer. Feel good about that. All right. 2/3 CIS 85 raised to the over an 8th power. That's a lot. Please stop running. You're making the video shake. We live in Kansas. There's not an earthquake around here for me to excuse that behavior. All right. So we get 2/3 raised to the 8th power. CIS 8 times 85. Oh, boy. I'm not a big fan of that, but we're going to go for it anyway. So powers of exponents, x over y raised to the a power is x to the a over y to the a. So that means we get 2 to the 8th over 3 to the 8th. Golly. I don't feel like figuring that out. I really don't want to. But I'm going to anyways. All right, so what do we say? 2 to the 4th is 16. So 2 to the 8th would be 16 times 16. Y'all might know that. 36, 3, 6, 7, 8, 9. So 96, 0, 1, 6 there. 6, 9, that's a 5, so 256. All right, so we got a 256. 3 to the 8th. I do have a calculator, but this is more challenging. 3 squared is 9, so that means we have 9 to the 4th. 9 squared is 81, so we have 81 squared. Ooh, that's not friendly, but just 2-digit multiplication. So we get a 1 and an 8, a 0, 1, and an 8. We get a 1, a 9, and an 8. That don't seem right. No, I goofball. I'm a goofball for sure. Why would I do that? Back out. We get a 0 here. 8 times 1 is 8. 8 times 8 is 64. Wow. 1, 16, 5, 6, 65, 61. Over 6, 5, 6, 1. All right, now 8 times 85, because I love that. We have 640 plus 40, so 680. CIS 680. That was not fun. I didn't like it. Oh, no, that doesn't go there. It goes here. We have 256 over 6561 CIS 680. That's my final answer. I just knew that. I didn't see that. Right. I was just showing what 2 to the 8th over 3 to the 8th is. That's better. Mathematically speaking, that's more accurate. Okay. Sorry. All right, keep going. Fundamental theorem of algebra. Why on earth are we talking about that right all of a sudden? All right, so for every non-constant single variable polynomial with complex coefficients has at least one complex root. All right, news fast. That's just to say that all equations have a solution. Thank, thank you. We've proven that all equations have a solution. That's what the fundamental theorem of algebra is telling us. I'm glad we know that. We call them corollaries of the fundamental analysis. This is what I'm talking about. Corollaries are a natural consequence, or some like if I know this, then I also know that this has to be true, right? So a polynomial with degree n has exactly n roots. Okay, so degree, largest exponent. So we can say largest exponent has that many solutions. So it also states a non-zero complex number will have two square roots, 3 cube roots, 4 cube roots, and k case roots. So non-zero, just meaning it's not zero. Zero is just zero. But all complex numbers have k number of kth roots, which just means there's that many solutions. All right, so there are k solutions. Not solutions, because it's not an equation. It's going to be k root for any complex number. I can take an infinite number of roots of a complex number. It'll still just be a complex number. All right, so here we go. It asks us to find the nth root of, oh, this is sort of De Moivre's theorem. This is De Moivre's theorem in backwards. So this is the pattern. So here's the pattern we have to follow. And I don't like the way that's written. Let's clear that up. Just so we know exactly what it's saying. It's saying the nth root of r cosine alpha plus I sine. No, let's not even do that. Let's just make it easy. Let's just, I want to make this easy. The nth root of r. Another way of saying that is r raised to the 1 over n power. That's going to be true. That's the information I want you to have right there. this is one and the same, and here's the formula that we're going to use. Now, this K value, what this K value is, K is equal to n minus 1. All right, so that's everything we really need to know. Sorry, I wasn't looking. This is everything we need to know in order to use de Moivre's theorem to find the root of any complex number. So, for example, if I want to equate this to real numbers that we know, so like the square root of 64, we know that to be 8, right? Or we could say the cube root of 64, we know that to be 4, right? Or we could say the fourth root of 64. Oh, I don't know what that is. Let's do this. Let's say the 6 root of 64 is 2. Right? So all it is saying is these are all of the roots. So these are the square roots of 64 are 8. The cube roots of 64 are 4. Because 8 squared is 64. Now, with complex numbers, different numbers can end up being the same. I know that sounds a little strange. What I mean by that is that this idea of like 4 plus 2i, that would be equivalent to 4 minus 2i cubed. Right? So these two numbers are the exact same thing. And so when we go through and look at a square root or a cube root or something, there's going to be more than just one value. There's going to be 3 values for that complex number. These are real numbers. All right, so these are real. Just examples of roots that you would know. Now we're going to take a look at complex numbers like 8i. There's going to be multiple of them. And in fact, since we're looking for cube roots, right, there's going to be exactly 3 of them. So, since we have z cubed equals 8i, what we're going to do is we're going to take the cube root of both sides, cube root, so z equals the cube root of 8i. And now, we're going to express 8i in the polar form, right, so that we can get to this formula that helps us here. All right, so 8i in polar form. 8i would be up here. My r value would be 8, and my theta would be 90 degrees. Let's just go with pi over 2. Would that be easier? More or less difficult? Would pi over 2 or 90 be more or less difficult? Let's go with, yeah, all right, theta, right? Let's go with 90 because I feel like that's going to be dramatically easier than doing a fraction with the numbers. So we're going with 90 degrees. So what we need, 8i expressed in polar form would be 8 CIS 90. So that means that z is equal to the cube root of 8 CIS alpha. But alpha is going to go into a pattern. We got to do k equals 0, k equals 1, k equals 2, all the way to n minus 1. And here, our n value is 3. So we got to go all the way to 2. So 0, 1, and 2, which would be 3 roots, and we're looking for a cube root. That cube just tells us that n is equal to 3 in all of this. All right, so this is where we're at. We're at right here. The nth root of r, CIS alpha. And now alpha is equal to theta plus 360k over n. So we get our theta, which we said was 90, plus 360 times 0 over n, which we said was 3. And that is, the cube root of 8 is 2. 0 times 360, well, that's gone. 90 divided by 3 is 30. So we get 2, yeah, 30. So that's one complex number. Whenever I cube it, I get 8i back. All right, let's go find another one. All right, we know that there's going to be 3 total. So that we started with k equal to 0. So now we're going to go to the next one where k is equal to 1. We're going to plug it into our formula here. So the cube root of 8, CIS, 90 plus 360 times 1, all divided by 3. So we know cube root of 8 is 2. I guess I can quit writing it like that, but I like putting the formula together the whole time, the whole way through. So 360 plus 90 divided by 3. So 450 divided by 3 is what, 150? Is that right? I feel good about that. Feel good about that. 150 to CIS 150. And let's see, does that make sense? Let's see. 360 divided by 3 is 120, right? And if the first one was 30 and we add 120, we get 150. Hey, that worked. Right? Looks like we're adding 120 every single time. Well, I guess we could have figured that out earlier. So that means the last one should be pretty easy. The third one, the cube root of 8, did it again, CIS, we get 90 plus 360 times 2 all over 3. Oh man, do I really want to do that? So 720 plus 90 is 810. Yep, 810 divided by 3 is 90. No, that's dumb. 1 divided by 6, 270. Hey, there we go. 2 CIS. Yep, 150 is 270. All right, it definitely checked. It definitely checked out. So the 3 roots that we have here. Let's just revisit this real quick so we know what we're doing, so we can do the next one quickly. Z is 1 cube root of 8i. Then z to the cubed is 8i. Express 8i in polar form, then solve the polar equation. So we started with z cubed equals 8i, did the cube root. And from there, we filled the form out 3 times, where k equals 0, k equals 0, k equals 1, and k equals 2. Right? Remember, the k value that we got is just n minus 1. How many roots are we looking for? Right? That's what we're looking to solve that. All right. One more here. All right. Find the 4/4 roots of negative 16. Express the roots in both polar and rectangular form. All right. Note the 4th root of negative 16 does not equal 2i. So it really wants us to find all the points in the complex plane. That's really what we're trying to go after here. All right, so the 4th root of negative 16. So z, I'm looking for complex numbers. Z to the 4th is equal to negative 16. And so I can raise that to the 1/4 power, which is the same thing as saying the 4th root of. Now I want to change this -16, since we're talking about complex plane now. I want to change that into polar, right? So let's go polar. -16 is going to be right over here. So that means we're going to have an R value of 16, and it's going to go theta of 180. Okay, so that gives us v equals 4th root. No, I don't want to say it like that. We're just going to say it like this. V equals 16 CIS 180 raised to the 1/4 power. There we go. That's what I wanted to say. So then we go, our n is equal to 4. N is equal to 4, so that means we're going to have 4 of these to do, right? N is equal to 4, so we're going to have 4 to go through. 180 is just pi, so I think we might be able to get away with this one. And no, let's just keep it in degrees. If I start in degrees, we'll leave it in degrees. All right, so we're going to start with k equals 0, and then we'll go k equals 1, 2, 3. Okay? Okay. So that is 16 raised to the 1/4 power. CIS. Our original angle, 180, plus 360 times 0, all divided by n here, which is 4. Oh. Now the 4th root of 16 is just 2. CIS. 36700, 180 divided by 4 is 45. All right, so we're going to let k equal 1 now. So we get, all right, the 16 raised to the 1/4 power, CIS, 180, our original angle, plus a full rotation, divided by 4. And I'm going to cheat sheet this thing. 360 divided by 4 is 90. So 45 plus 90, that puts us at 135. So we get 2 CIS, 137. All right, keep going. Now Z is equal to 2. Or sorry, K. Good grade. Maggie. I'm already struggling trying to concentrate. One 135/90 would be 225. All right, last one. Maggie. I love you, pal, but you gotta stop. Z equals 16 to 1/4 CIS. Start at 180. We add 3 rotations. Right by 4. So we get 2 CIS 315. There we go. And it says express the roots in both polar and rectangular form. Oh man, that stinks.
What?
We have to convert all of these polar coordinates, or polar expression of complex numbers. So that we got to express these complex numbers in rectangular form.
Okay.
So currently they're in polar form. We got to go rectangular. I know, biscuits, right? But it shouldn't be too terribly difficult. So we have 2 CIS 45, which means that our A value is equal to 2 cosine of 45. which is 2 times the root 2 over 2, which is root 2. Hey, that's not bad. And can we all agree that sine of 45 is going to do the same? Right? So sine would be root 2. So that number in rectangular form would be root 2 plus I root 2. And now take a look. This is going to be really, really simple. We added 90 every time, right? So 45 started up here, and if we add 90, we'll go here. And then if we add 90, we'll be here. Oh, so those are all of our roots. And we also know that 2 times root 2 over 2 is just going to give us root 2. So now we just have to make sure we have the sines and cosines in the right order. So let's make it organized. Let's organize our work. We have polar, and then we're going to have rectangular. So 2 CIS 45 in polar corresponds to root 2 plus I root 2. 2 CIS 135 corresponds to negative a, or negative x and a positive y, so a negative a and a positive y. And then 2 CIS 225, that would be a negative a and a negative b, so negative root 2 minus I root 2, because we're in quadrant 3, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4 would be 2 CIS 315. We have a positive a and a negative b. So, say that's all, folks.
That's all, folks.
Is it so? I bet it's not. Oh, it is. We did it.